So today what we're talking about is graphing trig graphs with a horizontal and vertical shift. Okay? All right, and I'm going to give you some steps to this as we do this particular graph, okay? So, before we even start, Lauren and I'm going to put the two graphs on top of our notes, okay? We're only graphing two graphs. Tomorrow we'll talk about tangent, but for right now, just today, it's just sine and cosine. So we know that the sine graph starts at 0. The sine graph looks like this. This is my normal sine graph. This is a y equals sine of x. And the normal amplitude goes from 1 to -1. And the period, or the width, is 2 pi. That's the period means the width, okay? Cosine graph looks very similar. It's also a wave. The difference is where it starts. Cosine graph starts up. And it goes through its rotation all the way down and back up. Okay? This is a y equals a cosine of x. So when I graph any of these two graphs, the first thing I do is I take a look and I say, okay, which one is it? Well, the example we're going to do is a sine. So we'll graph this one. Okay? 1, -1, 2 pi. Okay? So when I graph these, the very first thing I do is I just look at the shape. Okay, so step one of my steps. What are my steps? First thing I do is I'm going to either graph, so I look at the shape, meaning is it either going to be a sine or a cosine graph, right? In this example, it's obviously going to be a sine, so it's going to be this shape, right? Okay, the second thing I want to do, number 2, this is number 1. Number 2 then, so I want to look at the amplitude. The amplitude, which is the number in front. Okay, how tall it is. So the amplitude in this graph is 3. So I'm going to label it. I'm going to go up to 3 and down to -3. Okay, so I'm going to go 1, 2, 3, and I'm going to go down 1, 2, -3. Okay, so I know my amplitude. Okay. That's easy. Find the amplitude. It's going to go up to 3, down to -3. This shape, okay? Okay, the third thing I like to do is I want to find out what the period is. The period's like the width. Okay, and the width is always going to be, always going to be 2 pi divided by b. And b is considered what we call the frequency. B is the frequency. In our example, the frequency is 2. B is 2, so I need 2 curves. I need 2 curves within the normal 2 pi. So to find the new width, it's just 2 pi divided by 2, which is pi. That makes sense. Pi and pi, we get 2 of them in there, okay? Right? So we're going to take this, if I want to find the new period on this one, the new period, I'm simply going to take my 2 pi, always 2 pi, because that's the period of the normal curve, and divide it by the value of b, or the frequency. So divided by 2, and the new period is pi. That means that this graph here isn't going to go from 0 to 2 pi. In our example, it's going to go from 0 to pi. Okay? So the graph we're going to graph is going to go from 0 to pi, and then another one, so I get 2 of them in there, okay? All right, I'm going to do that. So 4. What I'm doing the fourth one is I'm going to graph. I'm going to start with the basic graph. So I'm going to graph my y equals my a trig of bx. Okay, what does that mean? Well, I'm going to either graph the sine or the cosine. I'm not going to do any shifting, no shifting yet.
Is that 3 of x?
That's b. That's a b. That's a b. Sorry, Ben. That's a b. So I'm going to graph up here. You guys have that written down? Up here, I'm just going to graph y equals 3 sine of 2x. Okay, I'm not going to do any shifting till the end. I will shift to the end. Now, when I do the graph, I do my 5 points. So let's see, if I'm going to go my pi halves, I'm going to go my pi, 3 pi halves, and I always like to go 4 squares, and you're going to see it's because of the 5 points. 3 pi halves, and then 2 pi, okay? So when I do this, I'm looking for my 5 points. I'm going to put down here, I'm going to graph it, I'm looking for my 5 points, okay? I'm looking for my 5 points. My 5 points are these 5 points here. So my 5 points are start, end, middle, top, bottom. Those are my 5 points, right? Those are my 5 points. And I put my 5 points right between here and pi, between 0 and pi, right? That's what I said. I'm going to put my 5 points between 0 and pi. So I'm going to do this shape here, but going to a height of 3 and down to -3. So here's my 5 points. I'm going to go start, end, middle, top, and bottom. There's my 5 points, okay? Now I'm just going to sketch that in. Okay, here's one curve. And then I'll do the 5 points again because I need 2 of these curves. Okay, so I'm going to go my 5 point start, end, middle, top, and bottom. And I'll bring my curve. Okay. Now, I have, oh, this one is supposed to go down to here. My bad, there we go, okay. So, here's what I have. I really do have 2 curves. I've got 2 curves, right? I really do have 2 curves, and the curve goes to a height of 3 and down to -3, okay? Now we're going to do a shift. We are going to always do, write this down, it's always the opposite of the inside. So we're going to do our step 5. We're going to do a horizontal shift. And it's going to always be the opposite of the inside. We've been talking about that all year, right? All year. If it's on the inside, it's going to be the opposite. If it says plus, we go back. If it says minus, we go forward, okay? So it's going to be the opposite.
So we're adding pi 4.
Yes, opposite, either back or forth, okay? And then we're also going to do, at the same time, let's do our vertical shift of,
Slide up.
we're going to also do our vertical shift of the 5 points, okay? So if we go to our 5 points, and we do this, we move the points forward pi force, down 3, down 1, okay, pi force. So here's what I'm going to do. You guys have that?
No, it's like,
Wait for you to write it. So we're going to take our 5 points, because if we move our 5 points, we're moving the whole graph. If you move your 5 points, you're moving the whole graph, right?
we got it.
Okay. So if I take a look, here's what I'm going to do. I'm going to take and move my 5 points forward pi force. Pi force happens to be right here. Pi force is there. I mean, if that's pi halves, that's pi force, right? So I'm going to take every one of my important points, I'm going to move it pi force and down 1. I'm going to take and move every point pi force down 1. Move it pi force down 1. Move it pi force down 1. 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 Let's do that. Take all of our 5 points. So, pi force is really 2 squares, correct? So, I'm going to go pi force down 1. I'm going to go pi force down 1. 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 And then we're just going to go ahead and draw in our new graph. So here's our sine curve that's been shifted forward and down. And of course, you know, it keeps going on forever and ever. I could go ahead and connect this, keep going more and more and more, but that is it. Okay? Now, you have your journals, right? Let's look at our journals, because our journal's going to look at it a little bit differently, okay? So, let's go to, let's see, 8.4. I'm going to go 8.4. All right. Okay. All right. So let's take a look. Let's go to page 239, okay? Let's go to page 239. So, here it is again. In our journal, the amplitude. In fact, they give us the equations. Here's our equation for sine. Here's our equation for cosine. A is the amplitude. How tall does it go? With one exception, if A were negative, we would just go down and up. Here's our cosine. A is the amplitude. B is called the frequency. It's how many curves you have, okay? This is my horizontal shift. It has the negative because in math it means opposite. Okay? And then up or down K. Cody? Here's the minus in math. It means opposite. That's why we go either the opposite direction. Okay? Now, same thing. They go through what's the period. The period is always 2 pi divided by the frequency. Same thing. Okay, then we got a horizontal shift the opposite way and then a vertical shift, right? So let's go ahead and turn the page and let's graph one of these. Oh, which one do I want to graph? None. Let's graph 6. Let's graph 6. Okay, now they don't make it long enough for me, but I'll just draw it in a little bit longer, okay? Alright, here we go. Let's do number 6. Oh, I'm going to have to squish it in. I think, well, let's go pi and 2 pi. Not a big enough graph. So pi halves is here, right? And 3 pi halves is here. What's the amplitude? What's the amplitude? What's the amplitude, you guys?
It's normal.
It is 1.
Yeah.
Amplitude is 1.
Did you go over 4 for that first pi?
I did, yeah, because they didn't give me a very big graph, Cody, so I had to make it a smaller scale. So the amplitude is 1, right?
Right.
So I'm going to go, I'll go by halves. 1, negative 1, okay. What's the period? What's the period? Well, it's always 2 pi divided by this number here.
1.
Right? You guys agree there's a 1 here?
Yes.
So it's always 2 pi divided by this number here. This number here is a 1. So my period is a 2 pi. So I've got my two shapes. This is a cosine. A cosine graph looks like this. Okay? So I'm going to graph that in using my 5 points. 1, 2, 3, 4, 5. My 5 points, right? Yeah, Cody?
When we graph in the graphs, do we always graph the original and the new one?
You don't have to. I do, because I don't make a mistake that way. Does that make sense? Some kids can go straight to the end. I've seen kids go and put the whole thing down. Like, oh, that's awesome. Me, I always do it in 2 steps, okay? It's just better for me if I do it in 2 steps, okay? So, step 1, I'm going to put this shape between 0 and 2 pi. So, let's see, it starts here, and it ends here. So, I'm going to do my 5 points, okay? I did that point and that point, right? The middle point is down at the bottom, right? The first quarter point would be right here, and the third quarter here. So, here's my cosine curve. Now, Cody asked a good question. That's not the answer. Because I'm going to shift it, right? So I'm going to shift it 2 ways. I'm going to shift it, so I'm going to do a shift on this one. And I'm going to shift it back pi halves, right? So to the left. And I'm going to go down 3, right? So every single one of those 5 points, we're simply going to move it to left pi halves. So pi halves is 2 squares. You guys agree?
Yes.
So I'm going to go back 2 squares and down 3. So every important point is going to go 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. I'm going to go 1, 2, 1, 2, 3. And my new cosine curve looks like this. And of course it goes on and on and on. It keeps rolling like a wave in the ocean. It just keeps going on. But that's basically the first curve. Okay. How's that? Thumbs up? All right. So